sure that the results are good. What we'd like to do now is capture a unit test for this graph. So here we have this new capability to create a unit test. So I go File, Unit Test, create a new unit test. And what it's asking me now is if I'd like to add test annotations that isolate the interior of the graph. And I'm going to go ahead and let it do its default work. And what it's done is it has inserted insertion sources on all of the inputs, where each insertion source reads data directly from a stable data snapshot for my application. And rather than reading from the upstream data source, it's actually going to isolate the graph by reading from my test data snapshot, basically injecting the data directly into the flows. It also has created test probes for each of the outputs. So rather than writing to the output, get an isolation test, we are going to extract the data, kind of like you would do with a watcher if you're familiar with the GDE, and compare it with data in the baseline. So at this moment, I have the shell of a runnable unit test. However, if many applications, the data doesn't always come out in the same order, right? It's slightly non-deterministic. If the data isn't sorted, or if you have volatile fields that change based on timestamp or the like, you need to add a little bit of training to each output comparison. So here I happen to know for my output file that the data is naturally grouped on place and building number, but it's not coming out sorted. So what I can do is specify when I run my test a key that will use to match the data. So I'm going to select a key, fill in the key for that, place and building number. And I also happen to know that this graph is basically identifying high-value households, and it's taking a representative customer from each, but I don't really care which customer I taken from each household. So the data is actually going to change a little bit on ID, the source, the first name, and the last name from run to run. This is some okay variability. Many applications that's not acceptable, but in this one it happens. All right, so now I have configured my comparisons. Having done this, my next step is to go ahead and save my unit test. So unit tests are, graph unit tests are saved as .tst files that live in the sample box. I'm going to go ahead and save it here. Replace my previous one. And now, my next step is to go ahead and populate some data capture. So the first step of this, if I were to run it in the GDE, is to basically run this data capture step. To run the graph and populate my snapshot directory with the values of the sources and the probes that run the graph. I've already done this, so what I'm going to do now is go ahead and just run the unit test. So if I've trained it correctly, this test is going to pass. If I've not trained it correctly, the test will fail. My virtual machine kind of like maybe some of you is a little hungover this morning. So give it just a minute. Okay, so it's starting to read data directly from the data snapshot area. Notice that these database tables, these components did not start, they did not run, because this is an isolation test, directly inserting data into the graph. And now the data is going through the graph, and I've compared the output with what I expect, and I see here that both of my two probes matched what I expected, and the test has passed. So at this moment, the test has passed. My next step is to go ahead and check in my test file and I can run that in continuous integration where I run the test for all the graphs in my project. Just as a quick view of that, you show that here in Jenkins you can schedule and run the test. So now I have a unit test, I have continuous integration set up to run it on a regular basis. Suppose I go ahead and make a change in my graph, or I've changed something in the environment. The test, if it's changing the data, the test will fail. So here I'm going to change the fudge factor that I have on estimated income. I'm going to give everybody a raise, bump it by 4. While I'm here, before I leave this, I will point out that as part of running a unit test, one of the things you can do is capture code coverage, and here it's being displayed in the GDE, the number of times that each line has executed. And lines highlighted in green are lines that were executed. So there's a little bit more coverage that we could get for this graph if we added test data that had estimated income greater than 200,000. Right? So these lines were executed. Okay, I'm going to save that. And now I'm going to go ahead and run this test again. I'll save the changes. And what do you expect will happen? Anybody?
Fail, right?
Yeah? Yep. Hopefully it'll show the difference. It should fail, right?
Yeah.
Please fail. So, here the data is going into my graph. We're doing the comparisons. And let's see what happens. Test is run, and indeed, this test has failed. And we can see that the comparison on the reject records was fine, but the comparison on the output file was not. And we have a summary here of what was wrong. Basically, some records were added because of our filtering criteria for high net worth individuals, and also there were some field differences. Here I can see that indeed the field differences were in the estimated income, right, which is now done. So if I like this, my next step is to go ahead and accept those test differences, which I can easily do from the GDE by going and accepting the differences. Right, so next time it would pass. If I didn't like that change, I should probably fix the code, right? Because I have a regression. All right. So I've shown you an isolation test of the entire graph. You can also isolation test individual subgraphs or small sections of the graph here. So as an example of that, I have this isolation test for our join component that has sources on all the inputs and one probe on the output of the join here, right? And does a comparison in that way. So that's another way that you can create a test. Let's see, what else should I show you? So, in addition to capturing in addition to the test, you also have test data that you need to keep track of and maintain. So one of the features of the test is that it knows what test data it needs and with what version. Now, what we don't do is check the test data into the METR, right? Because the test data can be really large and blow out your version history. what we in fact do is capture a snapshot, a fingerprint of the test data by basically taking a SHA hash of it through an action called packing test. And here, we're going to be adding buttons in the GDE for doing this, but I'll do it from the command line. So we can pack the test data for our test. And what that does is basically takes the directory that contains all the test data, takes a SHA hash of the individual files in there, packs it up, and stores the data snapshot with the SHA hash, and then sets up a test snapshot parameter in the test to tell you where to get the snapshot again. So the last thing I'll show you is that you can actually generate tests at scale. So there's a capability to look at, just like I've done in the GDE, automatically create a test. I can create a test from the command line by basically running a command. Here I have one that does that for all the graphs that are in my project. And if I hit refresh here, my test directory, I'll see all the generated tests. So this is how you can quickly get an edge if you have a whole schedule of graphs that you would like to add unit tests for. You can not only automate the generation of these, but also the capture. Okay, so some closing remarks of this is that recap of the workflow is that you develop your graph.